All right, guys, here we go, looking into section 5.2, okay? 5.2, we're going to start talking about what's called the bisector theorems, okay? So we have, if you will please remember, the, perpendicular bisector. Perpendicular bisector, as we see here, means you take a segment, like this segment AB, you pass through the midpoint of that segment with a line or a ray or a segment, and you make a right angle. Perpendicular bisector means cutting through the midpoint of a segment that is bisecting a segment and creating a right angle, which means perpendicular. So that we recall, and we will illustrate this theorem, Theorem 5.2, used in GeoGebra momentarily. Perpendicular bisector theorem says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of a segment. Equidistant mean of the same distance, okay? And we're going to illustrate this in GeoGebra in just a moment. Let's take it apart, see what it says. A point on the perpendicular bisector of a segment is equidistant from the endpoints of the segment. Notice 5.3 is the converse, that is flipping the if and the then around, okay? As you can see, if a point is equidistant from the endpoints of a segment, then it is on a perpendicular bisector of a segment. Okay, we're going to illustrate this using GeoGebra, okay? So we'll come over to GeoGebra, and we're going to get a couple more tools going here. We need a segment. Any segment will do, right? We know we have perpendicular bisector tools, okay? There's a perpendicular bisector tool. When we click it, it simply says, okay, click the two endpoints of the segment or click the segment, okay? All right, so there is a perpendicular bisector of AB, okay? It's cutting through AB and making a right angle, okay? We can illustrate that it's a right angle. We want to find that point of intersection, okay? So that's a point. That's a point. We need more tools. We need a point tool, we need an intersection tool, okay? And we're going to find the intersection between the segment and the perpendicular bisector. That's point C. If I want to show it's perpendicular, okay, then I got to put a point on perpendicular bisector. Another point tool, point on, okay? There's a point on. And that point on, of course, is, okay, free to move around, up and down, slide along any which way we want. Now, okay, we want to show again that this is perpendicular. We want a right angle here, so let's measure that angle, okay? From B to C to D. Okay, that's a right angle. And it's going to be a right angle. Now, nothing's happening yet as far as the theorem goes, because what's the theorem say? The theorem says a point on the perpendicular bisector of a segment. So that's what we got so far, the hypothesis. We have a point on the bisector of a segment. We want to show the conclusion is equidistant from the endpoints of a segment. Well, okay, let's go back to our sketch. Okay? So this point is going to be at the same distance from A as it is from B, regardless of whether this point is anywhere along this perpendicular bisector. So we're simply going to construct segments from D to A, from D to B, and we're going to measure those lengths, okay? Measure those lengths. And measure 6.4. GB, according to our theorem, should also be 6.4. There it is, okay? And again, this is a point on the perpendicular bisector, okay, which is free to move about. And however it moves, okay, however it moves, it will always be at the same distance from A as it is from B. There you can see it, whether it's above the segment or below. That distance is always going to be equal. which means that this triangle that we're looking at, and even if I manipulate A or B, okay, doesn't matter, okay, that point D is always going to be equal in distance from A as it is from B, which means the triangle I'm looking at right there is an isosceles triangle, okay, which means if it's isosceles, not only are two sides equal, the two angles are equal, mainly the angles at A and B, which also means that the two right triangles there are also congruent, which you should be able to show congruence very easily, any number of ways. Triple S would probably work most quickly for you. But, okay, there is our theorem. Again, our theorem says, okay, if a point is on the perpendicular bisector of a segment, then is equidistant from the endpoint of the segment. The converse is also true. We are not going to necessarily show the converse with GeoGebra, but we've shown that a point on the perpendicular bisector is always at the same distance from the endpoints of the segment that it's bisecting. And there you have it, okay?